So in this video, we'll look into topic 5.2, electronic configuration of an atom. So this is the part 2 video. Make sure you have watched the part 1 video before you proceed to this. It's very important to know the basic before you proceed to watch this video. So in this video, we'll look into a few principles and rules that we are going to use in writing a proper electronic configuration, whether in SPDF notation or orbital diagram. So let's start. First principle, Aufbau Principle. So what Aufbau is trying to tell you is you must fill the lowest energy orbital first. You must fully fill the lowest energy orbital first. When it's already full, then only you move up to a higher energy orbital. And when the higher energy orbital is full, then you move higher. So you must always start from the lowest energy orbital. And when they are full with the maximum electron, then only you move up to a higher energy orbital. But how do I know 1s, 2s, 2p, 4s, and so on, which one having a lower energy? So we have a diagram over here. And if you look at the diagram, n equals to 1, I have 1s, n equals to 2, I have 2s and 2p. When n equals to 3, I can have 3s, 3p, 3d. n equals to 4, I have 4s, 4p, 4d, and 4f, and so on. So we will cut the diagram from the top right corner. So the top right corner, the first when I cut through, I will cut through 1s. So the lowest energy of orbital that you need to fill in first is the 1s. And when the 1s is full with electron, you move on to your 2s. And when the 2s is full with electron, you move on to your 2p and then your 3s all the way down. So you need to fill your 2p and then you fill your 3s. When your 3s is fully filled, you move on to your 3p and 4s. So you move on to your 3p and 4s. 3p and 4s. Can you see the catch over here? After the 3p, you will proceed with the 4s. After the 4s is fully filled, and then you move on to your 3d, 4p, and 5s. So you will fill the 3d after that, followed by 4p, followed by 5s. And when the 5s is full, you will start off with the 4d, and then 5p, and then 6s. So you have your 4d followed by, you have your 5p followed after, and 6s. So this is the increasing energy of orbital. So we will start off with the lowest 1s, followed by 2s, followed by 2p, followed by 3s, 3p, 4s, 3d, and so on. Make sure s-orbital maximum is 2 electrons. So when 1s is full with 2 electrons, then only you move to 2s. When the 2s is full, then you move to 2p. p orbital maximum 6 electrons. So when the 2p is full, then you move to 3s. 3s is full, you move to 3p. When the 3p is full, you will then move to 4s first. After the 4s is full, then only you move to your 3d. And d orbital, we can take up maximum 10 electrons. The second rule that we have is Hund's rule. And what Hund's rule trying to tell you over here is, in a set of orbitals that have the same energy, the electrons will then fill in singly first before pairing out with opposite spin. First and foremost, what is meant by sets of orbitals that have the same energy? One of the examples of sets of orbitals that have same energy is 2p. So in 2p, we know that we have 3 orbitals. So in 2p, we have 3 orbitals. All this orbital is having same energy. So when they're having same energy, when you fill in electron, you must fill in singly first to every orbital before they pair up. It means you must fill the electron 1 into every boxes first. When every boxes having 1 electron already, then only you can pair out with the opposite spin. Another example that I can give to you is 3D orbital. So 3D orbital having 5 boxes. And we know that this is my 3D orbital. So what Hans rule trying to tell you over here is every boxes must get 1 single electron first before they pair up. After they have 1 single electron, then only they can pair out with the opposite spin. So bear that in mind. What Hans rule trying to tell you over here is when you have a set of orbitals that are equal in energy, you must fill in the electron singly first before you pair up with the opposite spin. Let's look into some examples of Hans rule. The example that I have over here is fluorine. Over here is your proton number. When fluorine is neutral, alright, so the proton number will be equal to the number of electron. So for fluorine atom, I will have 9 electrons to arrange. So for the SPDF notation, how should the SPDF notation start with? The SPDF notation should start with the lowest energy first. 1s, 2. So I already used 2 electron. 2s, 2. Bear that in mind, fluorine having 9 electron. So 1s2, 2s2, I already used 4. So 2p will be only taking 5. Why 5? 2 plus 2 plus 5, 9 electron. And that is the SPDF notation. The orbital diagram will look something like this. You have your 1s orbital label with 2 electron, 1, 2. You will have your 2s orbital with 2 electron, 1, 2. So for your 2p orbital, you need to put in 5 electron. So how do we put in the 5 electron? So the 5 electron need to place in singly first in a set of orbitals that have the same energy. So 5 electron will be placed in this way. 1, 2, 3, 4, 5. Singly first before you pair up. And that is what Hans rule trying to tell you. Last but not least, Pauli exclusion principle. Pauli exclusion principle stated that there will be no 2 electrons in an atom that have same sets of 4 quantum number. If you remember quantum numbers is N, L, M, S. Bear that in mind, every single electron will have one set of their own specific quantum number. It means that there will be no 2 electrons having the same set of quantum number. And we can solve this easily by putting in the opposite spin of electron when you pair up the electron. For example, I have 1s2. And we know that s orbital maximum can take up 2 electrons. And the orbital diagram looks something like this. 1s, the 2 electrons will be paired up in opposite spin. When the electron pair up in opposite spin, we'll look into the quantum number for this electron first. So the quantum number for this electron, n will equals to 1. Why? Because 1s2, so n equals to 1. It's an s orbital, therefore L equals to 0. When L equals to 0, m automatically becomes 0. And since the electron is going upward, therefore it's a clockwise, and s become positive half. So the quantum number for this electron will be 1, 0, 0, positive half. While another electron will have different sets of quantum number, but very similar. N will be still 1 because it's a 1s. When n is 1, n is a s orbital, so L is 0. And therefore m become 0. But it's spinning downwards, so it's anti-clockwise, and s will become negative half. So the electron quantum number will be 1, 0, 0, and negative half. So for the 2 electron in the 1s orbital will have 2 different sets of quantum number that will not be the same. The first electron will have 1, 0, 0, positive half. The second electron will have 1, 0, 0, negative half. So that is what we mean by Pauli exclusion principle. There will be no electron holding the same set of quantum numbers. So let's look into some example. The first example that I have on the screen is write the SPDF notation and draw the orbital diagram of boron. So the SPDF notation will be how many electrons? Boron, 5 proton number, so proton number is 5, and boron right now is neutral. So when it's a neutral, proton number will be equals to number of electron. So I will have 5 electrons to fill in. For the SPDF notation, we will always start with 1s2. And then we move up to 2s2. We already fill in 4 electrons. So one more will be the 2p1. While for the orbital diagram, it will be 1s will be 1 box. I have 2 electrons, opposite direction. And then I have 2s, same, opposite direction with 2 electrons. And 2p, I will have 3 boxes. That is my 2p. But how many electrons do I put in? Only 1. So single electron first. And we'll leave the rest empty. We cannot write only 1 box because 2p orbital having 3 boxes. Next example that I have is fluorine 9. We have talked about it previously. So the proton number over here is 9. And since it's neutral, so proton number is equals to number of electron. So the SPDF notation will be 1s2, 2s2, 2p, 5. Why 2p5? Because it's only 9 electron. So 2 plus 2, 4 plus 5, 9. And my orbital diagram will look something like this. Where you start off with the 1s, make sure you label them. So I have 1s, 2 electron. And then I have 2s, 2 electron. And then I have 2p, 5 electron. Remember what Hans rule say? You must fill the electrons singly first. So single, single, single. Pair up with opposite spin. So that is the 5 electron. I want to give you some extra question over here. What happens when I have ion F minus? Ion F minus. When it's a neutral, proton number is 9, number of electron is also 9 because it's neutral. But when it's an ion F minus, what happened to the number of electron? Number of electron increases by 1 because of the charge negative. So the number of electron will be 9 plus 1, which is 10. So we have 10 electron over here. How would the SPDF notation different? The SPDF notation will have extra 1 electron. So it will look something like this. 1s2, 2s2, and 2p, 6 because of the extra 1 electron. And the orbital diagram will also change with extra 1 electron, where you will see 1s with 2 electron, and then you have 2s with 2 electron as well. But the 2p will be holding 6 electron right now. And according to Hund's rule, you will still fill in singly first before we pair up. And what makes the F and also the F minus different is the number of electrons changing from 9 to 10. So when you're moving from 2p5 to p5, I'm having 2p6 in the F minus, the extra 1 electron that you put in to form ion F minus. I hope that helps you to understand more. Last example before we end, I have calcium 20. Let's see. So the proton number right now is 20. And since it's neutral, so the proton number will be equals to the number of electron, which is 20. So my SPDF notation will start off again with 1s, and we must fill until 20 electron is in. So 1s2, 2s2, 2p6. At this moment, we have 10 electron. And then we move on to 3s2, 3p6. After 3p, what do we fill in first before 3d? We must fill in the 4s first. So you can see the 20 electron will be arranged in 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 20 electron. And the orbital diagram will be something like this. 1s label with 2 electron, 2s label with 2 electron, 2p with 6 electron. Make sure you label 1, 2, 3, 4, 5, 6. Make sure they are all singly first. And then you have your 3s. 1, 2. And then you have your 3p. So you have your 3p orbital with 6 electron. 1, 2, 3, 4, 5, 6. Last but not least, you fill in your 4s with 2 electron. So that is for calcium neutral. What happened when I say my calcium now is ion calcium 2+? 2+ means what? It's a cation ion. When it's a cation ion, means electron is removed. So the question is, how many electron is removed to form 2 positive? There will be 2 electron removed. So when 2 electron removed, the calcium neutral, the proton and the electron is same, which is 20. So to become ion Ca2+, I need to remove 2 electron. So the number of electron left will be 18. So I need to remove 2 electron. Which 2 electron we need to remove? The electron that you remove is always the outermost electron. And the outermost electron now is in the 4s. Because n equals to 4 over there is at the outermost energy level. Whenever you want to remove an electron, the electron must be removed from the outermost shell, which is the furthest away from the nucleus. So we are going to remove 2 electrons from the 4s. And the SPDF notation for the calcium 2+ will be 1s2, 2s2, 2p6, 3s2, and 3p6. The 4s will be gone. Why? Because we need to remove 2 electrons. And the orbital diagram will be just similar as your SPDF notation for calcium 2+, where we will start off with the 1s with 2 electrons, followed by 2s with 2 electrons, 2p with 6 electrons, make sure you label them, 1, 2, 3, 4, 5, 6, and then followed by 3s with 2 electrons, followed by 3p with 6 electrons. 1, 2, 3, 4, 5, 6. And when you count, you realize that the total electron right now is 18. Always remember, whenever you want to remove an electron, the electron must be removed from the outermost shell, which is the furthest away from the nucleus. That is the rule to become cation. And that's it for this video. I hope you understand this video. And if you like this video, don't forget to hit the button like and subscribe to my channel. I'll see you again in the next video. Bye.